I'm Anil Kumar. Welcome to my series on global sharing. I believe that we all can share a lot from the best, which is all around us, and benefit. Here is an excellent question which had been asked in GCSE in 2017. It is based on cosine law. So every student in high school is working on cosine law, so I thought it's a good idea to share this brilliant question. So let me provide a heading here. We have an application of cosine law. That will act as a hint for you to solve this question also. Now let's read the problem. The diagram shows a hexagon A, B, C, D, E, F. So that is your hexagon A, B, C, D, E, F, right? So it's a concave figure, not a convex regular one. A, B, E, F and C, B, E, D are congruent parallelograms. So A, B, E, F and C, B, E, D, C, B, E, D are congruent parallelograms with AB equals to BC equals to X centimeters. So these sides are given to us as X centimeters each. P is a point on AF and Q is a point on CD such that B to P and B to Q is 10 centimeters. So these are the 2 points on these sides, so that if you connect them to B, you get 10 centimeters, right? So this is given to you. When you connect them to P, then what you get is 10 centimeters. So let's write it down. Okay. Given that the angle ABC is 30 degrees, so ABC is a bigger angle here. So that angle is given to us as let me write like this, 30 degrees. Prove that cosine of PBQ, the smaller angle, cosine of PBQ is this expression. So this smaller angle PBQ, let me call this beta, is all this. So that's your question. You can always pause the video, answer the question, and then look into my suggestions. Now, where do we begin? Let's read the question once again. It says that the diagram shows a hexagon where there are 2 portions which are congruent, right? And they are parallelograms. So these are parallelograms. So this drawing definitely is not to the scale, okay? Now, so if we are taking 2 points on the sides of parallelogram, joining them, you get 10 centimeters each, and we have the angle ABC as 30 degrees. Well, we can definitely begin with the triangle ABC itself. Now, if you look into the triangle ABC, then you see we are given 2 variables x, the sides, and the angle included as 30 degrees. And in our expression, we have x squared here, so it makes sense. So let's look into the triangle ABC. Now, in this triangle, we are given that AB is equal to BC and is equals to x. And we are also given that the angle ABC is 30 degrees. So that is a clear case of side angle side. Side angle side reminds you of cosine law, correct? So we can apply cosine law here and solve this particular triangle for AC, right? So let me write down what cosine law is. In any triangle ABC like this, we can write cosine law as the side, this AB square, let me write down here. So AB square is equal to, no, we say A because we are given AC square. Okay, let's write. So AC square is equal to AB square plus BC square minus 2 times AB times BC times cos of angle between them. Let's call this angle as B. That is cosine law, correct? Okay. So let's apply this cosine law to the given triangle and find what AC square is, right? So let me use a different ink. So we'll find what AC square is. So AC square will be equal to, in our case, x square plus x square minus 2 times x times cos of 30 degrees. Now cos of 30 degrees is what? Let's make our triangle here. Let's make it here itself. Okay. So in this triangle, we know cos will be, let's say this is 30 degrees. Then this is square root of 3, that is 2, and this is 1. Okay, so we know what cos of 30 degrees is. It is square root 3 over 2. So we get AC square as 2x square minus, this is also x square when you multiply them, and that is square root of 3 over 2. So these 2's cancel, and what remains is 2x square minus square root 3x square, which we can take x square common, so we get 2 minus square root 3, and within bracket we get x square. Well, that is half job done, since you have this numerator here, correct, which is matching for us. Perfect. Okay, now what? Now let's look into the other triangle PBQ, right, and then follow a similar strategy. I guess that should be perfectly fine, correct? So we've done one part, and here basically we found what is AC square. Okay, so we know AC square should be equals to PQ square. So we'll begin with AC square equals to PQ square, and both are equal to 2 minus square root 3 times x square. Fine. Now let's look into the triangle. Okay, let me make some room clear. So now we'll look into the triangle PBQ. Now in this triangle, what are we given? We are given that PB is equal to 10 units, which is same as BQ, and we need to relate the angle beta. So angle PBQ, I will write this as beta. Okay, so we'll work with this beta. So again, this is a case of cosine law, correct? Since it is side angle side, so we'll use cosine law. Does it make sense? Perfect. So we can write what PQ square is. So from here we say PQ square should be equal to what? 10 square plus 10 square minus 2 times 10 times 10 times cos of the angle, which we are calling beta, right? 10 square is 100 plus 100 minus 200 times cos of beta. Okay, so that's what we get. And here now we will rewrite this. Okay, so we have PQ square equals to 200 minus 200 cos of beta. We can take 200 common. Okay, so we get 1 minus cos of beta. Okay, so from here we can say PQ square over 200 is equal to 1 minus cos of beta, and that gives you, now rearranging, bringing cos beta here, cos beta is equal to 1 minus PQ square over 200, and we know what PQ square is, so let's substitute. So we get this as 1 minus 2 minus square root 3 x squared divided by 200. Right, so that is what is cos of angle PBQ. Clear? Correct? So that is cos beta. Right, so we just proved it. So that is how you could actually prove this particular expression. So I hope that makes sense, right? So in this limited space, I just kind of merged few statements, but I hope they are understandable. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. And we'll be sharing many such videos with you. So keep watching them and sharing them with your friends. Thanks a lot and all the best.